This module will guide the practitioner through the process of assessing the corneal shape. Determining the corneal shape is an important first step in the process of fitting the KeraSoft IC lens. It will identify which lens to try first from the diagnostic set and help the practitioner to understand the subsequent fitting characteristics of the lens. Irregular cornea conditions are divided into two main groups: natural ectasias and post-surgical corneas. In this module, we will be focusing mainly on natural ectasias. Post-surgical corneas will be covered in detail in the advanced fitting section. If the practitioner has a post-surgical case, it is advised to work through the core fitting modules, which describe the fitting process of the KeraSoft IC lens in detail. Natural ectasias, which include keratoconus and pellucid marginal degeneration, can be categorised into four groups, based on the location of the thinnest area. These are keratoconus with a central cone with a steep or flat periphery, keratoconus with a decentered cone, keratoconus with a low cone, pellucid marginal degeneration which exhibits limbal thinning. These categories can then be further defined by the severity of the ectasia, which may be mild, moderate, or advanced. There are key clinical measurements that will help to determine the location of the thinnest area and the severity of the ectasia. These measurements include spectacle refraction, visual acuity, keratometry readings, corneal profiles, and topography. It is important to remember that no one measurement should be relied upon to fully understand the corneal shape. Optometrist Lynn White will now guide us through how these measurements are used to identify the corneal shape, beginning with spectacle refraction.
Atypical spectacle refractions often result from corneal irregularity, and therefore they are a good guide to understanding the corneal shape. For central ectasias, the refraction tends to be more minus, with moderate levels of astigmatism up to around 5 diopter sil. As the severity increases, the spherical component of the spectacle refraction becomes more minus. For ectasias that are decentered or low, the refraction is usually either low plus or low minus spheres with higher levels of astigmatism in the range of 5 to 10 diopter sil. As the severity increases, minimal changes to the spherical component will occur. Very low cones and pellucid marginal degeneration, commonly known as PMD, typically demonstrate high levels of against the rule astigmatism, with severe cases presenting with up to 20 diopter sil.
Next, visual acuity.
Visual acuity is affected by the severity and location of the ectasia. Central ectasias, by their very nature, lie close to the visual axis. This means that the visual acuity is markedly reduced when compared with cases of decentered cones. Mild central ectasias may result in reasonable visual acuity, whereas advanced central cones will affect the visual acuity profoundly.
Next, keratometry readings.
Keratometry readings measure only the central 4 mm of corneal curvature. Mild cases of central ectasia can demonstrate normal to steep K readings, for example 7.7 to 6 mm. In advanced central cases, the K readings can be as steep as 3 mm. With low cones or PMD, the central K readings may be normal or even flat, for example 10 mm.
Next, the corneal profile.
This is viewed with the naked eye using the slit lamp. It allows the practitioner to see the overall shape of the cornea upon which the lens will be fitted. To set up the slit lamp to view the corneal profile, move the illumination system to the side and ask the patient to look straight ahead. Observe the anterior cornea from the same side as the illumination system, using the side of the patient's nose as the background. In natural ectasia, the corneal shape is influenced by the position of the thinnest part of the cornea. Therefore, locating the thinnest part will be helpful in identifying the corneal shape. The slit lamp can be used to locate this area by using an optic section to view the anterior and posterior surfaces of the cornea and observe the thinnest part.
Next, topography.
Topography maps the corneal shape and represents this with a colour-coded map. There are two main types of topography machine, scanning and Placido-based models. Each gives a different type of output. Generally, steep areas are indicated by the red colours and the flatter areas by the blue. This is dependent on the sensitivity setting of the individual machine.
In summary, the overall shape of the cornea in natural ectasia cases can be identified by looking at spectacle refraction, visual acuity, keratometry readings, corneal profiles, and topography outputs. The Corneal Shape Recognition Guide contains information covered in this module and will help to guide the practitioner in identifying the corneal shape. All of the guides featured in these modules can be downloaded from the Clinical Resources section of the training website.